In this video clip, we learn some basics of the binomial distribution. In a binomial distribution, we consider a problem with a fixed number of observations, denoted by n. For example, 15 tosses of a coin. Each observation is categorized as to whether or not the event of interest occurred. For example, head or tail in each toss of a coin. The two categories are mutually exclusive and collectively exhaustive. That is, when the probability of the event of interest is represented as pi, then the probability of the event of interest not occurring is 1 minus pi. We have constant probability for the event of interest occurring for each observation. That is, probability of getting a tail in our example is the same each time we toss a coin. Observations here are independent. That is, the outcome of one observation does not affect the outcome of the other. There can be many applications of the binomial distribution. For example, a manufacturing plant labels item as either defective or acceptable. A firm bidding for contracts will either get a contract or not. A marketing research firm receives survey responses of yes or no. New job applicants either accept the offer or reject it. In each of these examples, we have outcomes taking two possible values or falls in two categories. Here is the binomial distribution formula. We have Px, probability of x successes in n trials, with probability of success pi on each trial. X can be 0, 1, 2, till n. For example, if we flip a coin 4 times, let x be the number of heads. Then we have n equals 4, pi equals 0.5, assuming a fair coin. And 1 minus pi equals 0.5. Capital X can be 0, 1, 2, 3, or 4. Here we see an example. What is the probability of one success in 5 observations if the probability of success is 0.1? Here we have x equals 1, n equals 5, and pi equals 0.1. We can plug in the 3 values into the formula in the earlier page. Then we can obtain probability for one success equals 0.32805. We can solve the problem with Excel formula binom.dist. The first parameter x, second n, third pi, last false means non-cumulative. That is, probability for x equals 1. If we use true, then it means cumulative. That is, for probability px is less than or equal to 1. Example 2. Suppose the probability of purchasing a defective computer is 0.02. what is the probability of purchasing 2 defective computers out of 10? We have x equals 2, n equals 10, and pi equals 0.02. We can either use the formula or Excel function binom.dist to locate the probability.